Hi everybody. Thank you very much for joining this series of supply chain lectures. I am Johannes Vermorel and I will be presented product-oriented delivery for supply chain optimization. So first, when I'm speaking about product, I mean a software product. And for those of you who had ever, I would say, the privilege of investigating a bit, I would say, what goes under the hood of a modern enterprise piece of software, it might, I would say, be quite an experience, actually. And here, and for those of you who are familiar with the work of Lovecraft, I think there is some troubling similarities. The idea in Lovecraft has produced a whole series of novels. And one of the recurrent themes is the idea of, I would say, forbidden knowledge. It's not that the universe cannot be known. It can. It's just that the only thing that is actually preserving mankind is actually ignorance. Ignorance is not a problem. It's the very thing that protects us from, I would say, a universe that is too terrifying for the, I would say, where accessing the naked truth of the universe is something that is, beyond what our minds can tolerate. And literally, and this very idea has been, been recycled into many modern games, especially role-playing games, where in addition to the very traditional health points, you can have characters with health points, you can end up with sanity points, where if you do certain things that, damage your sanity, you lose sanity points. And the thing about enterprise software is that you need to be able to do enterprise software while preserving, I would say, your sanity. And obviously, this is one of the requirements to do anything that ultimately add value for the company. So let's proceed then. So why a product, and in particular a software product? Well, let's have a close look at how supply chains operate traditionally. Traditionally, you had, I would say, a lot of people on the ground, moving things around, shuffling package, driving vehicles, doing all the man-handling. And obviously, you had a lot of people in the production side, you had a lot of people in the stores, etc., etc. And what has gradually been happening over the last couple of decades is that the number of people that you had that had, I would say, blue-collar jobs has been declining steadily. It has been declining for decades. I mean, nowadays, production-wise, things are vastly automated. I mean, there are still a few industries like textile where it's very difficult to automate everything. And that's why those industries have been moved to where the manpower was the cheapest. But the reality is that I would say the raw manpower requirements have been lowered tremendously. And you end up with, I would say, a fairly odd situations where if you look ahead with autonomous, I would say, vehicles looming ahead, you will end up in a I would say, an odd situation where many companies will have more white collars dealing with Excel spreadsheets to basically run the supply chain, that they will have actually people with blue collars on the ground to do the man-landing operations. And that's kind of very puzzling. And that's exactly what I'm referring to when I say clerical work here. So, and also another thing that is quite peculiar is that supply chains have been digitalized for, I would say, for many companies, they have been digitalized for at least 2 decades. So it's not like we are going to introduce software into supply chain. Supply chains are already driven and operated via software. But when we look at what is the role of humans in those, software systems, well, humans are literally used in, I would say, your average supply chain system as a human coprocessor. So there are specific type of operations that where the regular, CPU, the regular processor in the machine, cannot do, and so the whole thing is delegated to a human. But then, in conjunction with, I would say, simplistic numerical recipes, let's say ABC analysis, min-max inventory, this sort of recipes, you end up in a situation where humans are doing all day long firefighting. So they're always dealing with exceptions, with exceptional conditions that just do not fit, I would say, the standard framework. And thus, from a cost perspective, this is all OPEX, operational expenditure. You need to pay an army of clerks every single day just so that all the mundane decisions, again, if you refer to one of my previous lectures, supply chain being the mastery of optionality, you need to pay an army of clerks so that those people can take all the mundane decisions that your company needs to take on a daily basis. What you buy, where do you put the inventory, do you decide to move one unit from one warehouse to a store, all those super mundane decisions that needs to be taken on a daily basis, where it's humans that are taking those decisions, or who are doing all the firefighting to cope with the inadequacies of the decisions that are generated automatically in a very naive fashion by the system. Now, my proposition for you today is that we want to move from OPEX to CAPEX. That's the whole point of this, I would say, product-oriented delivery. We want to basically build an asset. And why? Literally because it's super capitalistic. And if you look at the top 100 most profitable companies in the world nowadays, I mean, literally half of them in terms of profit-wise are software companies. And why is that? It's very simple. It's because software companies are literally the essence of the ultra-capitalistic company where you have an investment up front, and then you end up with literally a device, an artifact that is like a money machine that just generates added value with minimal marginal investment. And that's what we really want. And again, if we go back to the topic of my previous lecture, the point number 4 was we need robotization to put management back in control. And that's what I mean with automation. And humans, if there are humans in the loop, they are not there to basically deal with the inadequacies of, I would say, of dumb inventory policies like min-max. No, they should be there to basically add value, to improve the numerical recipes, and thus to act as strategists. There was this old-time IBM motto, which was computers are there to do the work, people are there to think. And that's exactly, the sort of thinking that goes into this presentation. So we want to have this, to turn supply chain into a capitalistic asset. And in order to do that, we need to turn supply chain essentially into a machine to deliver a software product. Now, what does this product do, actually? Well, it turned out that it does something that is actually fairly simple. It just takes decisions, and not, not arbitrary, open-ended decisions. I'm talking about the very mundane, routine decisions, like what do you produce, how many units do you buy from this supplier, from this other supplier, for this product, for this other product, how many units do you move from this location to another location. At first glance, it looks like a lot, but when you do a survey, you will typically see that even the largest, even the most complicated supply chains, there is only so many decisions that need, in terms of type of decision, that needs to be taken every single day. We are talking of a few dozens of different type of decisions, and that's not overwhelming actually. That's fairly reasonable, in terms of sheer number of features, and the interesting things is that. Those decisions are exclusive. So you see there are limits in what you can do in terms of divide and conquer approach. Once you've decided that you're going to purchase 100 units from this supplier, you can't have another subsystem that decides that you want to buy 200 units. At some point you have to make up your mind, how many units do you buy? How many units do you move from one location to another? There is those decisions are discrete, and they are limited in scope, and they are also largely exclusive. So that's pretty much it. We want to have a piece of software that will generate in a completely automated fashion all those decisions every single day. That's what we want. Now, one thing that is usually, I believe, exceedingly poorly understood about software are the notion of diseconomies of scale. So obviously most of you, I suspect, are actually pretty much familiar with the idea of economies of scale. So obviously the economy of scale, it takes, if I want to ship one tiny package from China to Europe, it will take, I would say, the cost will be much greater per gram than if I want to ship one full container. And and I'm referring, to the cost of shipping per gram of merchandise to be moved. So that's typical, economies of scale. Is when you do things, at scale, the costs are lowered. This is true in supply chains. This is true in manufacturing. This is true in advertising. This is true in pretty much, at every single point of the chain, actually. But when it comes to software, the opposite is true. We have significant diseconomies of scale. But what is the scale about? The scale is about the number of features that we're looking at. So, and there is this motto that adding 1/4 more features double the cost. And it's actually fairly steep. And that explains, by the way, why you can have, tiny startups that seems to rival very large companies. It's because those tiny startups are just going to do, a small fraction of the features that the product of a large company has. But because they are only doing, a small fraction, the cost to actually bring this product to the market is literally, it can be, only 1,000 times less than the cost that the large company has been paying to actually bring the super complex product to the market. But think about it. We have a lot of things to handle, I would say, in terms of capabilities if we want to deal with all the situation that we have in terms of supply chains. So I'm presenting this idea of diseconomies of scale because I've just said that we want a product. Now the question is very simply, should we build or buy or even something else, this product? We could decide that we are going to buy this product from a vendor, and that would be it. That would work. Question is, this vendor is going to be subjected to those diseconomies of scale. So let's have a look at all the features that the software vendor will have to actually deliver to be able to serve a market. So let's buy, a supply chain optimization product off the shelf, shall we? And here on those slides, I give you once again, to review of those lines. I've just listed a tiny fraction of all the things that we need, and I have first-hand experience of that because when I started, Lokad, the company was created in 2008. It took me, first I started with a very small software product that was oriented for, more oriented toward forecasting than supply chain optimization at the time. But the problem, the essence of the problem was pretty much the same. I was basically facing a client, and then I realized, oh crap, there is so many features that capabilities that I do not have. And so I tried to add those capabilities, and then I was moving to another client, and then I realized that there was another whole swath of capabilities that were also missing. And then, 4 years down the road, every single time I was meeting another client, I was realizing that there was another big chunk, and it seems to be completely endless. So just have a look at, just the core features. So what are we talking about? First, we have companies that are like B2C or B2B, completely different patterns. For example, supply chain wise, if you're a B2B company, it means that you have literally 2 orders of magnitude less clients, but those clients, they are ordering 2 orders of magnitude more stuff. And so you can have plenty of type of risks, such as, for example, if you're B2C, you don't really care about losing any of your clients. You don't want to lose clients on average, obviously, but it doesn't matter. You could lose any of your clients is kind of replaceable. If you're B2B, sometimes you have situations where you have one client that literally do 10% of your turnover. That's not necessarily super healthy, but that's just the way it is. So your supply chain is at risk that if you lose one client, it can completely disrupt your supply chain. And then you have things that are more complicated, like B2B2C or B2B2B. And then let's have a look at, for example, just the sites that you have to cover. A store, for example, it will, especially a store that is exposed to customers, you will have inventory inaccuracies pretty much by design. And by the way, it doesn't matter if you have RFID or not. As soon as, a client can take a product and move it, put it back on the shelf, 2 meters from where it's supposed to be, from the perspective of the clients walking to the store, it's missing. So the thing is lost. So you have plenty of, I would say, edge problems that comes from the fact that it's a very messy environment. Warehousing obviously comes with a lot of specific problems, same for plants. Primary, I'm referring to a primary production site. It can be, a farm or a mining rig. And typically it comes with its own specificities as you have uncertainty of the production yield. Now you can have echelons, you can have like single echelons, too many. We have clients that have, up to a dozen echelons. And obviously it's very, very different from if you have just one echelon or 2 echelon, you have like solutions that are way easier than if you have like a dozen echelon. And then you have the network topology. So a tree is just, the forward, the classical supply chain forward path, where basically you have a tiny few production sites that dispatch to several warehouses that are dispatching to many more branches. But then you can have DAG. A DAG stands for direct acyclic graph. So it's a typically sort of situation where, for example, one store can be served by one or several warehouses. So basically, it's not just a tree in terms of graph. It can, reconnect, although it's still only forward. But the same thing, you can have a DAG when you have like multiple suppliers. Then you can even have loops in your supply chain graph. That happens whenever repairs are involved. And that's, for example, all the MROs found in the mining industry or in the aviation industries. You have tons of repair loops with repairable equipments. Now, the inventory itself, there is not just one nature of inventory. It varies a lot. You can't just say, oh, I have this idea that I have SKUs and this is it. No, not quite. Because you have raw materials that are literally measured in quantities, in grams, in kilograms or whatever, in volume. Then you have the eaches that are the nice clean units that are, I would say, mostly prevalent. But then you can also have like lotted inventory that happens very frequently, for example, in pharma or in the food business, where all the whole lot comes with specific expiration dates. And then you can even have like completely serialized inventory where every single unit has its own serial number. And that has, in terms of supply chain optimization, that completely changed the game. So it's completely different problems wherever you're looking at each one of those things. Then obviously you have all the problems of the marketplaces. And at Lokad, we have clients that are in literally every single possible solution. We have clients where they sell on a marketplace that is like a third-party marketplace. They can have their own marketplace, or they can have both, or it can be something that is secondary so that they can use it to basically liquidate the things that they didn't sell. So there are many, many situations. Now, just for example, think of once again, what is an order? You have the spot order where basically you just, buy something and right off the counter, you buy something and it's yours. So it's like a spot order. But then you can also have an order that says, I'm buying it, but I don't want this thing to be delivered immediately. I want it, I'm buying now, but I want it to be delivered 1 month from now. Obviously, from a supply chain optimization perspective, it's a completely different game, because if you know in advance that you will have to deliver a certain quantity of stuff at a specific date, you don't want to forecast that. So it's a completely different thing. And then you have a configured order. And that's, for example, when you buy, let's say, a computer online, and you can choose, how much memory, how much hard drive you have, what type of operating system, what is the language that will be set up for your computer, what will be your keyboard, all sorts of things. So you can have like a massive configurator, and that change again. That also happens for things like bikes or cars, and that completely change the landscape when you have this sort of things, because again, it gives you options and way to look at the supply chain optimization problem that is completely different. And then even, for example, for prices, you can have, the per unit price that is flat, super simple, super linear, but it's not the only thing. You can have price breaks. For example, if if you buy 10, then you get a discount, or that's the price breaks, or you can have loyalty programs where some clients that have a loyalty card can get a discount, but only on certain type of products, or only depending on certain conditions. And then you can even have, in B2B, it's very frequent, things that are negotiated. So it's literally, yes, there is a transaction, a lot of things will be, sold, but you have like a regular catalog price, but there is a vendor that can give a rebate to a client because they are important, and it's just the way it's being done. So bottom line, and I have not even, I've barely, I've been speaking for minutes now, and I've only covered, the core. I haven't even started to touch the must-have things. So just pause for once again and try to think what an off-the-shelf enterprise software product that is supposed to deliver supply chain optimization is going to look like. It's the number of features that we have to cover is just literally insane. And when you try to think about how to put all those things together into kind of a monolith, you're literally losing your mind. And we are back to this idea that it's not that the universe cannot be known. It's just that if you're exposed to the naked truth of the universe, you just lose your sanity. So literally, we have a major problem. And here we have to differentiate, supply chain management from supply chain optimization. That's a distinction I already introduced in one of those my previous lectures. Is that there is a big confusion going on between the management side and the optimization side. The management is just about bookkeeping. It's about supporting the workflows, supporting mostly a data entry processes. And if you want to represent all of the things that I've just described, it's a lot of ground to cover, but it's doable. An obese ERP can do that. Yes, you will end up with 10,000 tables. It's going to be pretty ugly, but it's possible. But make no mistakes, the ERP, which should be named, ERM, Enterprise Resource Management, it's not going to be doing much. It's just merely going to keep track of those things. So you will have like tons of entities, MOQs, check, I can represent MOQs, I can represent price breaks, checks, I can represent stores, checks, warehouse, checks, but I don't need to have any degree of intelligence. It's just about mundane digital counterpart to reflect so that it's possible to enter the data into the system. And this is it. And it's possible, and because here we can cheat a little bit about this rule about 1 quarter more features, double the cost. There is something I didn't really say about it. It's that it works, you can escape this curse if you keep your features completely segregated. So as long as the features do not interact with each other, it's okay, you're not subject to this curse of diseconomies of scale. But from a data entry perspective, there is no problem. You don't need to have the user interface that lets you drive the MOQs that has anything whatsoever in terms of logical connection to be connected with whatever is letting you add an extra store to the network. Those two things can be completely segregated. But when it comes to supply chain optimization, the same is not true. If you have MOQs will have profound implications on how frequently you're ordering, how frequently you will be delivering things from your warehouse to your stores. There are plenty of, I would say, far-reaching consequences. You can't segregate things because ultimately your supply chain is just one system where everything has an influence on everything. So from a supply chain optimization perspective, you literally have the problems that all those things have to be, plugged in if you want to deliver optimization, and that's where things falls apart. So on the management side, you can potentially end up with a product. on the supply chain optimization, the answer is, yeah, you can't. I mean, you can pretend to, but literally you can't. And even on the Lokad side, Lokad was started not as a company that specialized on predictive supply chain optimization. Initially, if you go back on the Lokad blog, back in 2008, I started as forecasting as a service, and I was thinking, let's just do time series forecasting. That was severely misguided, but nonetheless, that's how I got started. And literally, even for time series forecasting, which is like a tiny subset of the whole problem, even there, it's actually unmanageable. That's my conclusion after being in this business for 12 years or so. Now, if we have to go back a bit to the specific world of producing software, it's something that is very specific, and unless you've been trained as a software engineer yourself and kind of familiarized with the way that large software, I would say successful software companies are actually producing software, and chances are that you know just very little about it. And it turned out that it's a very specific world with plenty of things that are vastly counterintuitive, and usually, especially I would say traditional companies that are more, I would say, of the classical mechanical engineering mindset or the marketing mindset, they literally are struggling immensely to wrap their head around how software is working at all. We will be covering these things, I would say, in greater details in future lectures. But there is one book that I really like that was produced by Joel Spolsky, who was at the time already an ex-Microsoft employee who had been working in the early teams of Microsoft Excel. And by the way, it's the same guy that also later on produced Stack Overflow, some of StackOverflow.com. He's one of the co-founders, and he's also the guy that co-founded Trello. So he has quite a track record, and back in 2004, when I was only a student, I read his book and his blog at the time, and it's literally, I'm just reading the title out loud because it's a whole piece of work. Joel on software and on diverse and occasionally related matters that will prove of interest to software developers, designers and managers, and to those whether by good fortune or ill luck work with them in some capacity. And that's this book with a lot of humor, gives you a grasp of what actually running a software business successfully looks like. And it's very different from probably what most people outside this industry are expecting. So I will be basically, by the way, adding the detail of this book in the description of the video. But let's keep in mind more specifically that supply chain optimization is not your average software product. Usually when you deal with an average software product, I mean, yes, you have some adversarial behaviors, obviously. Depends on which type of software products. Obviously, if you're YouTube, you can have plenty of people who are posting, hateful content or whatever. So it's social networks are world games of their own. But if you're doing with, I would say, the classical enterprise piece of software, something, let's say, like Microsoft Word or Excel, it's a product where basically you want to have a product that has the right design, but then there is no emergency whatsoever, And by the way, you can literally think very strongly about the design, spend years refining your design, refining your products, and it's okay. It's literally long-term investment. You have to look decades ahead. There is no reason whatsoever to rush anything in terms of development. But supply chain optimization doesn't work like that. You don't get the choice. Stuff happens all the time, and the terrain is very rugged. You can have things like the most extreme things are probably this year, the pandemic, but you can have all sorts of other problems. You can have ransomware, and then half of your network is shut down. You need to emergently, take smart decision to make the most with the capacities that you still have at your disposal. You can face, what part of your fleet might get grounded because there was like a tragic incident, as it did happen with 737 MAX. You can suddenly have political moves like tariff that completely disrupt, your strategy, because suddenly it makes some of your, supply path completely, uncompetitive. You can have tsunamis, and again, if you look at the last 2 decades, there were several major tsunamis that brought, I would say, vast disruption to Asia. So it's something that is not so frequent, but it does happen, once per decade at a very, very large scale. You can have fires and heat waves, just like it happened, in California or in Australia this summer. And so there are always stuff happening, and the essence is that when those things happen, you need to be able to react literally in hours. So you have your software product, yes, but you need to be able to bring change, and you want to bring programmatic change, because again, remember, you don't have, if you're in this mindset of delivering, a software asset, you have a small team, a small target team that is driving the software that in turn, drives your supply chain, but you don't have an army of clerks, who are just doing firefighting all day long. And even, and by the way, you could say, oh, but then you disprove the point that you need an army of clerks. I would say, yes and no, because the army of clerks, when you have an army of clerks, you need to train all those people. And guess what? Whenever there is something that is completely unexpected that just happened, you end up with an army of clerks that has not been trained for this specific situation that was completely, unheard of. So my experience is that the more people you have to manage, the longer it takes to achieve anything. It's just, again, another sort of diseconomies of scale. And by the way, I could not resist. It was, I think, like 3 days ago, one cargo ship just lost over 1,800 containers due to bad weather conditions, and that's the things that just happen. So and you cannot hope that to basically eliminate those things. Again, supply chain is not like manufacturing. Manufacturing, you may have a production site where everything is completely and tightly controlled, but by the very definition, supply chains happen in a world at large where most of the time you have no control over the elements, over, there are so many forces that are beyond your control that you need to be able to cope with surprising things. Yet, you already know that those surprises will happen. So you need to be prepared, and be prepared is not to have everything carefully mapped out. It's just to have a system where you will be able to react in hours if you need to. That's the essence of what you can do to realistically approach the problem. Now, what do we need in terms of software ingredients for supply chain optimization? Well, we need versatile data storage, just to represent, all the diverse type of data sources. We have seen that there is so many things that we want to represent. So we want to have something that is very, very versatile in this regards. So we can have tons of structured data and a lot of variety. Then you want programmable logic. So again, I'm going back to this idea. If you do not have, programmable logic, how do you cope with all those problems? How do you glue all those things together? You cannot buy. There is zero hope to buy a product off the shelf that will have everything pre-programmed for you. That do not work. Sorry. So you want something that is versatile user interfaces, because again, the way you want to look at your problems is going to vary enormously from one situation to the next. The KPIs are going to be completely different. Again, that's in my previous lectures, that's those dollars of rewards and error I was describing. Well, it's going to be completely different from one company to the next. So you need to have a versatile user interface where you will be able to, present the numbers in any way you see fit, because otherwise it's going to be a big problem and a big limitations. Then you want collaborative capabilities, because if you don't have that, I mean, again, supply chains is teamwork. It's by definition, there is a lot of people involved. It's distributed, so you need to have collaborative capabilities at the core. And also, that's the last thing that is maybe a bit counterintuitive. You want programmable capabilities, but they should be accessible to people that are not trained software engineers. And that is very, very important. There are many reasons for that. One of them is because first, there are not that many people that are, I would say, trained software engineers in the job market in the first place. So it's very, very competitive to hire those people. That's one reason. It's not the biggest, but it's one of them. The other, actually more profound reason is that it takes so much effort and dedication to become a talented software engineer that it's very, very difficult to become a supply chain specialist as well. It's just like maybe you will find, grand chess master who happen to be also be super good at ski or soccer, but it's not that frequent, I suspect. Most of the time, if you're dealing at things at scale, you need to find something where you can find people on the market. There is not so much to learn that it's completely overwhelming. So software engineering is super, super tough. Supply chain is super, super tough. So if you want to have somebody who has, dual competencies at scale, I mean, it just do not work. And the same thing would be if you want to find, somebody who is both a programmer and a lawyer, a programmer and a doctor. I mean, yes, you will find some of those people. There are some of them out there. But can you do that at scale? Can you do that reliably if you're a large company and bring, a few more of those people every year to your company? I'm not sure. Frankly, and my experience of running Lokad for a decade is that it just do not fly. So you want to have something that is programmable, but you don't have to be a professional trained software engineers to basically deal with all those programming. And remember, you need to have someone who has supply chain competency because you need to be able to cope within hours to apply, the programming corrective to your system without, opening a ticket and passing the ticket to IT. Because if you have to do it that way, then things takes literally weeks to get addressed, not hours. So what kind of software can actually solve the problem? Well, actually, Excel can. It's not pretty. It's not, it might not feel like the pinnacle of modern software, but it does the tricks. I mean, it ticks all the boxes. Versatile data storage, yeah, kind of. I mean, you can certainly put a lot of data of any kind, in Excel. Programmable logic, absolutely. Excel is completely programmable. Thank you. So certainly it ticks the box. Versatile user interface, well, absolutely. You can have, bar charts, line charts. You can have plenty of things, plenty of ways to present the data. So in terms of user interfaces, it's very versatile. It might not be, the most packaged user interface, but in terms of versatility, clearly it can do a lot. In terms of collaborative capabilities, well, it's kind of crude. You have some version of Excel that are online that are marginally better, but fundamentally, minimally, you can share your spreadsheets. The problem is not, when you want to do collaborative, the problem is not, having the spreadsheet on your desktop or online. That's just, it doesn't change much, really. The problem is that just the mindset that goes behind spreadsheets is not suitable for intense collaborative work. I mean, usually, if you have a colleague that has created a very complex sheet, usually it's actually easier to recreate the sheet as opposed to try to figure out what your colleague did. So the problem with the lack of collaborative features is not the fact that it's a desktop app, like the traditional Microsoft app. You can take, the online version. It doesn't change anything. The problem is the mindset that comes with spreadsheets, where it's by design, there is very strong limits to what you can do in terms of collaborative. And obviously, it's completely accessible to non-dev. And there is even, visual basic for application that is even there if you want to go, I would say, on things that are even more complicated. So software, I would say, in terms of ingredients, I believe that Excel is ticking all the right boxes. And so it explains, I believe, to a large extent, the success that Excel has operationally in most supply chains. Because let's face it, in my experience, literally the quasi-totality of the supply chain nowadays in the world, from the smallest companies to the largest, from the companies who have never invested a cent in an enterprise piece of software to the companies that have invested, dozens of millions of dollars into super complicated pieces of enterprise software that are supposed to deliver supply chain optimization. In all those situations, the supply chain is driven by Excel. There are very, very few exceptions. I mean, sometimes people are actually, through Excel, they are just revising the min-max. There is a piece of software that is the system software that actually apply, min-max rules, but then all the maintenance of the min-max settings are actually delegated to people who are working with Excel. So literally, Excel is driving the world of supply chain at the present date. And I believe it's not accident. It's because at the core, the spreadsheets are fundamentally correct on a lot of things. And you can see that there are many of other options that are presented as superior that fails by default. If you can't program, that means that whenever you face a major problem, a major emergency, you're screwed. So that means that basically people will fall back to the Excel spreadsheets. If you're lacking versatile user interface, well, the minute you can't have the numbers the way you want them presented, you're going to fall back to Excel spreadsheets. If it's not accessible to non-dev, so it's only IT team that can bring stuff, then what will happen? Maybe the first 3 months, people will open tickets and pass it and wait patiently for IT to deliver. But you can be assured that within 3 months, everybody is falling back to the Excel spreadsheets because it's just way faster. So literally, there are a lot of things that are, I would say, necessities. So if you don't have a solution, so my belief is that Excel is not the end game, but whatever we bring as a superior replacement, whatever we pretend could be a superior replacement, it will need to tick the right boxes. Now, how can we make something actually better? Well, in terms of versatile data storage, Excel is good, but it's not very scalable. So if you want to process millions of lines, it's just not very scalable. Even with the modern Excel flavor that can process, 1 million lines, it's not. You will face performance issues very quickly whenever you operate at scale. Programmable logic, yes, but it's very, very fragile and brittle. What do I mean by that? I mean that if you inadvertently introduce a mistake, a bug, if you want, in your spreadsheet, being able to debug that, to investigate, to pinpoint the source of the problem is going to be a nightmare. The problem is that the logic is endlessly duplicated. So you end up with, literally thousands of copies of the same logic. If there is in a few places things where it diverge, is going to be a mess. Then again, same thing about the user interface. It's a mess. It's not exactly web-based. I mean, it can be web-based, but it's not exactly super lean just because you always have the data in front of you and completely entangled with your user interface. Collaborative capabilities, yes, but again, it's quite messy, again, because you want to collaborate on the code. That's the point of collaboration should be the programmable logic. That's where you need collaboration. I mean, very frequently you will see vendors that propose to collaborate on the outputs. What do I mean by collaborates on the outputs? For example, there are many supply chain optimization vendors that tell you, oh, you can tweak manually the forecast, and you can bring a lot of people to the table that will tweak the forecast visually. But it's completely the wrong way to look at the problem. Because again, this is, if I go back to this idea, of coprocessors is literally you say you have an army of clerks and you want to keep all your army of clerks busy so that they can actually tweak the forecast, all day long. So they not only they will be tweaking the min-max inventory settings that exist in your software, but they will also be tweaking things like forecast. So that's completely the wrong way to look at the problem. Collaborations need to happen, but it needs to happen at the logical level, so at the level of the programmable logic. And obviously it has to be accessible to non-dev, and my criticism for Excel is also, although it is very accessible to non-software engineers, whenever you want to do anything that is a tiny bit complicated, and remember in supply chain we want to deal, that was in my previous lecture, you want to be able to deal with all possible futures. So fundamentally you want to be able to deal with things like probabilistic forecast, random variables. You want to frontally address the uncertainty. And it's possible in Excel, but it's actually fairly complicated. So yes, Excel is very easy on the simple stuff, but as soon as you start to move on slightly more complicated stuff, it can become, you literally have to become an Excel wizard to actually deliver that. Although to some extent it's programmable, it's always possible. And then maintainability matters. You want to build an asset, you want to build something that really, where the value of whatever your numerical recipes, it grows over time. And with spreadsheets, it's quite difficult to achieve that. I mean, at best, you will have a slightly lower OPEX with a slightly higher productivity, but it's very, very difficult to end up with things that are built on spreadsheets to have something that is truly accurate, at least in the sense of a software product. Now, the buzzword of the day is probably things like AI, but also Python with all I would say all the trend and the buzz the hype. Sorry, that's the word I was looking for. All the hypes that surround data science. But to a large extent, I believe that Python is actually, for most supply chain, inferior to Excel. So I know that a lot of people maybe in the audience are actually loving Python. I believe that it's an awesome language. No question asked, by the way. I'm teaching, I have a 10-year-old daughter. I'm teaching programming to her. And guess what? I have chosen Python to teach her programming. So don't get me wrong. I love Python. I believe it's a brilliant language. But, and there are many buts. My first but is that it is failing us. I mean, it's very interesting because back in 2012, when basically the data science hype was emerging, in North America, Lokad, I was already working with North American clients, e-commerce style, and I was already noticing that all the Python prototype were failing me, failing my clients as well. It was very easy to come up with prototypes, but it was near impossible to get them, to bring them to production. And it was ongoing. So there was like an endless stream of prototypes that looked very promising at the time. And then we were trying to bring them to production. And 1 year down the road, the whole thing was actually, usually discreetly phased out because it wasn't working. It had never managed to acquire the production gradiness it takes to be really something that becomes like a core asset. So again, why is that? I mean, again, if I go back to where is actually Python doing a worse job than Excel, is first, it requires software engineers. Yes, Python is probably one of the most accessible programming language out there. I'm able, to teach basics to my 10-year-old daughter. So it's certainly very accessible. But whenever you want to do, something a tiny bit complex with Python, you need to have a software engineering team. Otherwise, the whole thing collapses on itself once it reaches, a certain complexity, a certain amount of time, a certain number of contributors. So that is a big problem. Again, if you have this requirement that you need to have people that are both supply chain experts and software engineers, you're in for a very, it's going to be very, very tough. Then Python is super nice, but the way dependencies are handled is quite complex. Package management is poor. I mean, if you look at the forums of Python, by the way, the packages are building blocks that you can bring it to get extra capabilities, because usually when you say, oh, I want to use Python, it's not exactly Python that you're interested in. You're interested in, I don't know, in NumPy, in Pandas, in TensorFlows, in Scikit, all sort of third-party dependencies or software libraries. So package management has been poor for over a decade. It's improving, but very, very slowly, and there is plenty of things that in the very design of the systems make it super difficult to actually improve. And performance is poor pretty much by design. And by the way, the performance in terms of compute performance, so what do I mean by compute performance is what is the quality of the job done by Python to basically exploit the metal performance that the raw compute performance that you have from your computer. And to a large extent, Microsoft Excel is doing a much better job. Actually, it might come to a surprise to a lot of people, but Excel is extremely optimized. It's definitely leveraging out of the box multi-CPU, multi-cores when you have a computer with multiple processors. It is compiled natively, the logic. Microsoft has invested a lot to make Excel super, super fast. So Python, in contrast, has a lot of problems that are by design, and where literally you frequently end up with something that is 100 times slower than what your machine could, in theory, deliver in terms of raw compute performance. Maybe you would say, oh, it's okay, computers are so powerful nowadays that we don't mind if we are like 100 times slower because it's still good enough. I would say, yes, but no. I mean, not when you're operating, any company that is $50 million and above. The number of transactions that you're dealing with is going to get large. It's going to be a problem. So you want something that gives you, good performance out of the box, and the idea that you can take something like Python, but let all your calculations happen in a third-party library like NumPy, so that you get the performance that you want. Then you had one problem, which was the lack of performance of Python, and now you have two problems, which is lack of performance of Python plus all the extra complexity of NumPy that you have to deal with and maintain over time in addition to Python. And again, if you start adding all those libraries to bring some kind of speed-ups to Python, then you're significantly raising the bar on the software engineering side of the problem. So beware. Yes, you can make Python faster with those special components, but you're creating complexity too. And all of that, again, what sort of problem does it create when you want to basically go to production from a real supply chain perspective? Well, it creates and that was the problem that Lokad was facing back in 2012. You face things like null reference exceptions. You have problems like out of memory exceptions. You have the amount of time that it takes to compute. You frequently end up in doing things where you run a computation, you wait for 20 minutes, and then you start thinking, is this computation ever going to complete? Or should I wait for hours, or just kill the thing and restart? I just don't know. So you want things where you have a very, very good idea on how much time it's going to take to complete. By the way, if I go back to Excel nowadays, when there is an operation that takes a bit of time to complete, Excel will give you a fairly reliable indicator, a progress bar on how much time it's going to take. So again, you want, and that is part of what I refer to as the production gradiness. You want to have something that is, because again, the software that you're producing is most likely going to run unattended. It's just literally it's going to run during the night, during the nightly batch or something. You want something that do not requires a data scientist to babysit the whole thing. And again, if you have the problem with data scientists, then you had a third competency. You had supply chain expert, software engineering expert, and now you need to have like a data scientist expert. That's again, it's possible to have all those three qualities into one person, but good luck with hiring more than one person a year, even if you're a large company that has all those skills. It's just super rare. So we want to have something that will improve. By the way, so first thing that we want to improve is defense in depth. Ransomwares are on the rise. And whenever you put something programmable in your organization, you expose yourself to ransomwares, because suddenly, when you have a program, the program on the machine can do tons of things, including hijack the very machine it's running on. I know that there are tons of ways to mitigate the problems. You can sandbox the things, you can restrict, you can have limited rights. You have tons of ways to basically limit the problems. Nonetheless, whenever you have something like a general purpose programming language, your attack surface area, that's a technical term, is absolutely gigantic. So basically, whenever you're plugging code like that, you expose yourself massively in terms of security problems. And remember, the way it's typically done in a regular software business is just the code is peer reviewed. So you review the code. You have like a whole review process. Somebody produces a code, and there is a colleague that is going to review the code to make sure that there is no shenanigans, in the code. But if I go back to the fact that software has to be rugged, you have to be able to respond within hours. You will not be, from a supply chain optimization perspective, to have like a code review process in place. It's just not compatible with the delays and the emergencies that you will face. So you need to have something that gives you defense in depth by design. Then you want to have something with transparent performance, where yes, things can take time, but you need to be in control. You need to know in advance how much time it's going to take. If you don't have that, then you expose yourself to tons of very stupid problems, like you had a 2 hours window to deliver results, and you're late. And you know what? The trucks have already left. They don't have, it's too late. So you need to have something where it's taken care of. And same thing about the transparent upgrades. That's the beauty of Excel, is literally you don't have to think about the maintenance of Excel. Microsoft basically, they signed a pact in blood decades ago, which was if you've produced an Excel spreadsheet, whatever next version of Excel will land in the market, this version will be able to support your spreadsheets. And the most incredible things, if you look at Excel nowadays, it supports many competing Excel formats of competitors of Excel that are gone, that don't even exist anymore. You can still read things like spreadsheets that were produced with Lotus Notes and this sort of things. I mean, so Microsoft, their value proposition in terms of transparent upgrade, their value is the logic that you've produced will work forever. And yes, we will keep improving Excel for decades, but you know what? It's taken care of. That's not something, when you look at the transition from Python 2 to Python 3, it was a nightmare and it took a decade. So literally, I would say, again, Python is great for many things, but just imagine that there is those upgrades will happen at the worst moments where you have the worst pandemic, the worst tariff, the worst emergency, and you need things to be up and ready. You cannot afford to have like a 6-month downtime just because you need to take care of an upgrade. That's not something that is compatible with supply chain optimization. So now we need to think of what if we were to actually consider something where it would be engineered for supply chain in mind. That will be, by the way, the topic literally of the next lecture. Now, also, supply chain is not a division of IT. When I say, a product-oriented delivery, again, it's not the software is just a mean, not an end. You will not be selling your software for licenses like for a fee, like let's say Microsoft is doing. IT is literally in this vision that I'm drawing in front of you in this lecture. IT is responsible of, I would say, the core practices, the core IT practices, what you should do or should not do in terms of, security, backups, the core infrastructure, your network. How do you manage to synchronize everything in terms of data at the company level? And and basically also providing all the guidance and the coaching. But the idea is that supply chain needs to own the supply chain decisions. They need to own all the apparatus that generates those supply chain decisions. So that's their co-ownership. Again, the previous lecture I said what define, the supply chain scientist. The supply chain scientist is someone who owns the numerical decisions produced by the code. It's not a system that produces the decisions. It's numerical recipes that have been written down by one or many supply chain scientists, and those supply chain scientists collectively own, those numerical decisions. They take ownership in that, and the responsibility of supply chain is to make sure that all the decision pan company are consistent. That if basically there is a promotion going on, a big marketing push, that things are produced in time so they are ready to be served, that you don't end up in I would say, a catastrophic situation where you're pushing something where you're already in a near stock out situation, where you spend money, on a marketing push for something that you can't even sell because you don't have the stock or the capacity to manufacture them or to produce them, service them, etc., etc. So literally we have two divisions that are very strong, I would say, that have very different focus. And in my, I would say, ideal vision of what should be the IT department, the IT department is not where a division where you pass tickets. This is not the way it works. The IT department is literally in charge of the core infrastructure. It's the sort of things that just work seamlessly all the time. You don't even pay attention. Just like, the Wi-Fi is working, you don't pay attention to the Wi-Fi. You only pay attention to the Wi-Fi when it's not working. A good IT is delivering all the infrastructure so that you don't even pay attention to them. You don't even realize they exist because it just works. Just like, your emails, it just work flawlessly, etc. That's what good core IT is about. And then it's the sort of people that are coming to you and helping you establish all those, practices that give you a hand of, again, programmable logic is a bit hard. So sometimes, where are you going to get the coaching to get a little bit better programming-wise? Well, the answer is it should be IT. IT should come not to say we are going to code it for you. We are just going to coach it so that you can actually implement it yourself. We help you with a few concepts. We maybe help you with some things that are a bit more technical than it should be. You have like sometimes you have like accidental complexity. So IT is there to support you. But fundamentally, they are not there to do the work for you. They should be mentor and coaches and make sure that nobody is doing like a terminal mistake that would expose, the whole company to something like a risk of ransomware or something, that would be like a systemic risk IT-wise for the company. And then, as a litmus test, I would say, again, if you think in terms of specifications, and if your interaction between IT and supply chain goes through documents where you list specifications or requirements, this is just nonsense. This is not the proper way to have a good relationship between those two divisions. And when I say a good relationship, I mean something that will actually add value for the company. Okay, so in conclusion, we have two challenges here. From, I would say, the traditional supply chain management side, that have been doing, programming, but just at the edge through Excel spreadsheets, not even necessarily realizing that it was already a form of programming. You have to overcome your fear. You have to think that the world of tomorrow, your division will be in charge of delivering, a product that is running like a software product, and that is an enormous change. Yes, but it's something you can deal with that. Why? Because if you have the right tools, yes, there are programming involved, but it's not fundamentally radically more difficult than Excel. And again, the challenge is not in the technicality in the tool. It's literally the problems literally lies in the supply chain challenges, in the complexity of the supply chain itself. So the problem is difficult not because your tool is difficult to handle, but because you have a complicated supply chain in the first place. So that's the biggest thing that you need to overcome. And then for the part of the audience that is maybe more on the, I would say, data scientist side of the audience, or maybe the IT side of the audience, what you have to overcome is overconfidence. I have seen again and again data scientists, and I include myself, in this category, that were overconfident in their capacity to bring the prototype to production. This is tough. This is really tough. And those things, supply chains have a way to blow up in your face in the most surprising way. I can only remember, one anecdote where years ago we started with a leading European auto parts e-commerce. And literally, we had our forecasting technology, and we were basically proposing to handle the part replenishments. We do the forecast, we do the suggestion, part replenishment, so that's an e-commerce serving car parts. And we do that. Next week, we see that all our forecasts are off by factor 2. The demand has doubled. What the heck? What had happened was literally their number one competitor had decided to go on multiple countries at the same time. At the point in time where we were starting our forecast, one of the competitors had decided to go on all the national TVs and start broadcasting their service online. And the interesting thing is that my client was not even aware of that, and they had better search engine optimization results. They were more optimized in terms of SEO. So basically, people were seeing the TV ad for the competitor, but then they did not necessarily remember the name of the competitor. So basically, they went to Google and they were typing car parts, and so they were ending up on the website of my client. And so, in order to demonstrate, how great Lokad was, the first week where we were starting, we were off by factor 2, and we were thinking, what the hell is even going on? And so we had to revise everything, because literally when you see that the thing double, it's not that everything double. It's that some things are doing 10x, and a lot of things are just untouched. So that's the sort of things, and you need to be able to react like super swiftly. That's what it's about. So fear and overconfidence. Thank you very much for your time. So I will be having a look now at the question through the chat. Oh, okay. So we have people that are asking questions right from Australia. So it's very late. Thank you very much for attending. That's heroic, I would say. So can the software make the decision about which supplier to place an extra order in the event of needing more for tomorrow? So here I would separate, and then example, 200-gram punnets of strawberries in the off-season Australia may have 10 suppliers delivering the same products into the distribution center in the same day. Absolutely. And here we have to differentiate the two sides about the supply chain management and the supply chain optimization. There is the supply chain management side. It's literally to have all the data pipelines in place, including EDI, where you have literally, you can push an electronic order to a supplier with no human intervention whatsoever. So you have like an electronic bridge end to end. But then that means that you need to have on the optimization side a piece of software that just runs continuously through the day, and that at some point can notify the management side and say, please execute this order. And then on the management side, which is going to be managed by IT, they just make sure that this thing is completely executed, but it's just a matter of pure transactionality. There is no intelligence anymore. You have received an order where it says this quantity, and it's the optimization side that is responsible to make sure that when you generate, a certain quantity, you're compliant with all the constraints, such as what are the exact list of suppliers that are even eligible to serve these products? Do they have any stock left? How do I make the right choice between all the competing suppliers, etc., etc.? There might be plenty of things going on. I would say absolutely yes, but we literally have to separate the mundane execution of that is the transactional part that lies on the supply chain management side from having at the point of time, which might even be during the day, that at a point of time you decide that I need to reorder more. And that's the optimization ingredient. Then Carl-Eric DeVaux. do you know you are competing with esports world championships right now? Do you know? Yeah, I mean, no, I'm not competing with those esports championships right now, and but it's very cool, you know. By the way, at Lokad we are doing Dota games, frequently Dota 2, so the whole management plays Dota. And but some of our employees want to play League of Legends, but we, as a CEO of the company, I firmly disapprove. And okay, another things. So from Pankaj Nenani, I've seen that many businesses do not have the ideal ERP or WMS in the first place, and that management is working on supply chain optimization. Well, absolutely. I mean, you cannot avoid supply chain optimization from day one. You have to take those decisions, you know. So in a way, supply chain optimization was there even before there was any kind of supply chain management software-wise in place. Because even if we go back, you know, 60 years ago, there was zero software. People still had to take the decision. So supply chain optimization was already a thing. People were doing it with pen and pencil. And if you look at the earliest, I would say, supply chain, you know, supply chain works, such as the Wilson formula, also known as the EOQ formula, it is 1 century old. So it clearly precedes software. So yes, supply chain optimization is something that happened that you from day one, no matter whether you have software or not in your organization. Now, indeed, you need to have proper IT systems, but I would say it's a completely different mindset. You know, supply chain management. The problem is that what you want is something that do the very, I would say, mundane stuff, dumb stuff, very well, which is just plain data entries, potentially with, you know, support for barcodes and this sort of things. But it's about very, very mundane things. It's just about representing the data. So usually the problem is that people, they want something that do both, that do supply chain management and supply chain optimization. And as a result, you end up with a product that is overcomplicated and that is usually super buggy, and you need to have like bad features like alerts and exceptions, which are very, very bad. You should avoid them. I will be getting back to that in a later lecture. But fundamentally nowadays, deploying a WMS or an ERP, if you don't already have one, it's literally a matter of weeks. If you already have one, it can be a matter of months if you de-entangle this thing from your decisions. And then the second question, yes, when can management of the business realize it's time to move from tracking information to optimize supply chain decisions and eventually start focusing on supply chain optimization? I mean, the first thing is that you even have to realize in the first place that there are two problems, and that your software will never, the same piece of software will never address the two angles. And that's, I think, the grand illusion. And software vendors have been, I would say, incredibly, I would say, had incredibly confusing message in this area. You know, if you look at the biggest ERP vendors, it's nearly, if you look at what they are pushing in terms of message, all their message is about supply chain optimization. But all that they actually deliver and all the things that their product actually do is on the supply chain management side, which is much less, I would say, sexy, because there is no AI, there is no actual intelligence. It's about, in the software world, it's known as CRUD app, you know, create, raid, update, delete. Those ERPs, they are just gigantic collection of CRUD screens where every single screen can create, raid, update, delete lines from a relational database, and this is it. And ERP is basically, I'm simplifying, but it's literally a collection of thousands of tables where you, for every, you know, sort of entities that can be a tiny few tables that just are grouped together logically, you have 1 or 2 screens, and this is it. So literally, you have these problems. And so if I go back to your question in terms of management, the problem is that if you're a manager, you read the brochure of the ERP vendor, and the ERP vendors tell you this thing is going to optimize your supply chain. And the answer is not, absolutely not. What it's going to do is that it's going to create it's going to improve productivity to have the accurate bookkeeping of your supply chain. This is it. But by the way, this is it, but this is already a lot. It means that, it can dramatically reduce the amount of theft, the amount of shrinkage, the amount of misplaced goods. It can dramatically improve, the productivity with barcodes where you can just flow things super fast through a warehouse. So there is a lot of I would say, added value by those products. I'm not dismissing at all the value that an ERP or WMS bring to the table. It's enormous, but it's not about supply chain. And by the way, for example, a WMS is by design something that cares about the warehouse. It is by design, it does not care about the whole supply chain that includes clients and suppliers. It is by design something that is focused on specific locations, not the whole chain. Now, how can you, another question from FroXX1203, sorry, it's pseudonyms. How can you smoothly transition from Python to a vision or have them work together? We did have them work together in a few situations. Historically, it was mostly because when Lokad started Envision, which is, by the way, for the audience, Envision is a domain-specific programming language designed by Lokad that has been engineered for the sole purpose of the predictive optimization of supply chains. By the way, in the next lecture, I will be demoing Envision so that people can have a better grasp of what I'm talking about with real bits of code. So wait for it. But so back to the question of Python plus Envision. So historically, we did that more than I would like, mostly because when we started, Envision had very, very limited capabilities. So there were tons of things that were just missing. So we were defaulting to Python in many situations. Over the years, Envision, we have been at it for the last 8 years, since 2012, so it has been, why. Over the years, we have gradually expanded the capabilities so that we have gradually phased out the very need to have, Python components, but it's not just Python components. It's also, for example, you need something to orchestrate, all your logic. You can plug Airflow, which is another product, but you can also have like built-in capabilities. So it's not just Python, it's also a series of tools that supplement the practice that needs to be plugged together. So yes, and by the way, the syntax of Envision has on purpose been aligned in many aspects in terms of style. It's very close to Python. I did made the choice, a conscious choice to basically design the syntax of Envision in a way that was not antagonizing Python programmers, so that if you're familiar with Python, literally in a week you will know Envision. I mean, it differs in subtle and profound ways, but syntax-wise, it's literally, there are many aspects that are literally the same. And I believe it's just because Python is a lot of things, and there are a lot of things that are downright excellent. The simplicity is very good. There is a certain purity to the design. I mean, even if I say that it doesn't ticks all the boxes, and that creates in production severe problems that cannot be recovered, it doesn't mean that Python is without merits. That is not what I'm saying. I believe that Python has a lot of merits. Again, we are talking specifically of how to run in production supply chains, which is a very, very specific problem. Now, bouncing off, so a question from Pierre Garcia, bouncing off Pankaj's question, then how would you make a client understand that his ERP is not optimizing anything? That's very tough. That's very, very tough. Because, I mean, frankly, the problem is that literally the worst case situation is that usually prospects, they're not clients yet, prospect comes to me and their question is, say, our ERP, we have like a legacy ERP that is not delivering any value. And now we want to go to the next ERP. That's the typical situation. And can you deliver all those things? And we want something that delivers supply chain optimization. And that's a terrible situation for me, because then I have to basically tell the client what you're looking for is not one product, but two. One that will replace your ERP and do basically the management side better, and one that does the optimization. And usually, when you think about those legacy ERPs, I have a lot of respect, especially for those, AS400 products that have like a command line terminal on, those old school IBM mainframes. When you look at from the management side of the problem, usually they are just doing a very fair job. This is not the problem. So if you start looking about what you're really looking for, yes, having a web interface rather than a command line would be nicer, but will this make your teams on the ground more productive? I challenge that. The command lines with text terminal can be incredibly snappy and productive. No distraction. It doesn't look good, but what you want is people to be able to do their operation the fastest way, the most reliable way, zero distraction. Those systems can be actually very good and have been over the years very polished to do exactly what you need. So usually it's quite difficult because then we have to de-entangle all the nonsense that have been pushed by all our competitors. And if you add on top of that, we have to explain that first the ERP is not going to do that, and then we are going to explain that no, there is no such thing as AI. It's absolutely nonsense. You have classes of statistical models maybe, and then you don't have blockchain either, and also the sort of nonsense that is pushed by vendors. It's pretty terrible. So usually we lose most of our prospects at this stage. Sorry, I just don't have. That's one of the reasons why I'm doing those lectures in the first place, because literally it takes hours to get to the bottom of it and explain the why we need to see the problem the way I see it. Richard Morgatroyd, what's your recommendation for a platform to address combinatorial complexity of planning multiple products with probabilistic demand distribution? That one is so easy. Well, Lokad, of course. But bear in mind that being the CEO of Lokad and being the main shareholder and owner, majority owner of this company, I do have, some kind of a conflict of interest in my opinion. So I'm deeply convinced that Lokad is the platform that you need, but please understand that it's also that also happened, the company that I own and that I run. So I will do my best to remain, objective when it comes to that. But by the way, Lokad has been literally engineered to deal with those probabilistic demand distribution. And by the way, it's not just probabilistic demand distribution. It should be probabilistic lead time distribution, probabilistic return distribution. Again, we need to look at, that was the topic of the next lecture, we need to look at all possible futures with probabilities, but all the types of uncertainties. Demand is a very important one. It's usually the most important one, but it's not the only one. Okay, I think I've gone through those questions, just checking if I missed anything. No further question. So thanks everyone for watching this lecture, and see you next week, same day, same time. See you soon. Bye.